Hi, I'm Cassie DeSutte, and this is my report on system and integration testing. I chose the article Rapid Embedded System Testing Using Verification Patterns because a large portion of what I do is actually testing. I thought this would be a good article to read because it applied so much to what I do. The abstract is a pattern approach to testing real-time embedded systems lets developers customize test script templates and reuse them throughout an application's lifecycle. The verification pattern approach helps to reduce the time it takes to write tests by allowing programmers to reuse the code they have already created for a test script. This article discusses the advantages of the verification patterns along with the architecture and real-world applications of verification and scenario patterns. Embedded systems require vigorous testing before they can be released to the public. This means multiple functional, structural, and integration tests need to be created and passed. On top of that, embedded systems are usually complex, which adds to the difficulty of creating tests. This can become very expensive and time-consuming quickly. Testing scripts usually include thousands of lines of code and take weeks to create and run. For every scenario, there needs to be a test written, in turn adding more programming and time to a project. Verifications help in developing tests quickly. According to the article, the developing and debugging of test scripts take up to 70% of integration testing. The verification pattern approach allows test engineers to reduce the percentage because they are reusing reliable tests. Systems are usually specified by scenarios. A scenario includes specific details about how the system works. For every scenario, there is a test script. In a typical medium-sized program, there can be upwards of hundreds of thousands of scenarios. Those scenarios can be very similar or complete polar opposites. The pattern-based verification approach is based on taking the large amount of testing scenarios and reducing them to be more manageable. Testing is an important step in software engineering. It helps to identify bugs and errors in the software, which in turn minimizes system updates in the long run. Although testing is important, it does add programming and time to every project. Many times, a system will have duplicate or similar scenarios. Since every scenario needs a test script, this leads to multiple tests. Verification patterns help in developing tests quickly. The verification pattern approach takes similar scenarios and groups them together to create common categories. Once categories are created, the test engineer will create a template for those patterns. That way, when a test engineer goes to create a test script, if it falls into one of those categories, they can create a test based on the template. This approach helps to reduce cost and effort. The authors of the article applied the verification pattern approach on medical devices as well as a car alarm system. They found the approach to be very advantageous. The car alarm system included 20 scenarios with 5 scenario categories that covered 100% of the tests. Using the verification pattern approach in the medical systems reduced the lines of code from 136,623 to only 16,300. I'd say there's a huge difference. Although the verification pattern approach has many advantages, it can be disadvantageous for systems that have a large number of scenario patterns. The more scenario patterns, the longer it takes to analyze the patterns, create script templates, and implement. From personal experience testing software, the verification pattern approach is a method I've already used, although the method didn't have a name at the time. It has saved me a large portion of my time to be able to reuse test scripts while testing a large program. There are even testing techniques that embed reusing tests in their methodology. For example, in iOS testing, a method called Frank, which uses Cucumber and Ruby, encourages testers to make tests that can be reused for different scenarios. Tests are created with placeholders instead of text. Then, from the scenario files, those placeholders are replaced with specific text. For example, say I'm testing that a button works. That button will have a specific UI button name. Let's give it button X. My test then becomes when I touch button X. This calls the test and uses the button name as a variable. In the end, the verification pattern approach was created to save time and money. And let's face it, in most situations it does. When you have a program with few scenarios, it doesn't take long to go through and group each scenario into scenario patterns. From there, creating tests should be simple because they are developed by recreating and customizing tests that already exist. I am glad that I chose this article because it applies to me in many ways and it will help me with testing in the future.